Jai Hind to all. My name is Manoj Kumar, Assistant Professor, Department of Computer Science and Engineering, Akgec Engineering College, Ghaziabad. Today, in this video lecture, we will learn about the segmentation method of memory management. This will be the content that I will cover in this video lecture. First, introduction of segmentation, then user view of a program, then segmentation hardware, and segmentation example. So, segmentation. Before segmentation, discuss to segmentation. Actually, segmentation is a memory management method. In context to the operating system, memory management is a function, important function of an operating system. And in context to memory management, operating system perform the various activity, like it to provide the memory space to the process, and it deallocate the memory space from the process when the process completed, and operating system also keep the track of memory space utilized by a particular process at any instant of time, and operating system also keeps the track of total memory utilizations of the system at any instant of time. So these are some basic activities which operating system perform in context to the memory management. So segmentation is also a memory management technique. There are two types of memory management techniques. First one, the contiguous memory management, and second one is the non-contiguous memory management. In case of contiguous memory management method, the total available space must be available in contiguous manner in order to load the process in the main memory. What happen whenever the memory space is in non-contiguous? Memory space is available, but that is available in a scattered manner, that is not available in contiguous. So in that case, non-contiguous memory management methods are used. In case of contiguous memory management, multi-programming with fixed size partitioning and multi-programming with variable size partitioning techniques are used. And in case of non-contiguous memory management technique, paging and segmentation is used. So segmentation is basically a memory management techniques which comes under the category of the non-contiguous memory management method. So segmentation is a memory management scheme that support the user view of the memory, and a logical address space is a collection of segment, and each segment has a name and length. The address specify both the segment name and the offset within the segment. What happen in case of segmentation? Actually, it support the user view of memory. This is the main focus of the segmentation. This is the main concept behind the segmentation. Actually, whenever a user visualize a program, then user can visualize a program in form of segments. It is a collection of part, or it is a collection of segment. It means a program may be visualized as a collection of segment. So here in segmentation memory management method, the program is visualized as a collection of segment, and every segment has in two parameter associated with it. First one is the segment name and segment length. And in context to addressing, each segment has a particular segment number and the size. Length is also known as the size. And to identify the segment, we can use the segment number. Okay. So the user therefore specify is addressed by two quantities, segment name and the segment offset. For simplicity implementation, segment are numbered, and for recognition purpose, segment number is used instead of the segment name. So, and are referred by the segment number rather than the segment name. Okay. When we write a program, then we think is at a collection of a different type of set. Like this is the visualization of a particular program. Suppose there is a program, then we have divided it into 5 segments. Segment number 1, segment 2, segment 3, segment 4, segment 5. Segment 1 is our subroutine, segment 2 is SQRT, main program, symbol table and stack. So here this is a complete program which is divided into 5 segments, and here each particular segment has associated with two things. First one is the segment number, and second one is the segment length or segment size, you can also say. Okay. So here suppose like a C program. In C program, first section is of header file, second section is for the global declaration, third section is the main function, and after that user defined functions are used. So in the same way, a particular program can be visualized as the collection of the segment. Next one is the segmentation hardware. what is the segmentation hardware? Actually, whenever a CPU want to access the data from main memory in order to execute that data, or in order to execute that instruction, then CPU basically generate the logical address. So at first, in segmentation hardware, a logical address is generated by the CPU, but actually the instruction is stored at the physical address. And physical address, where does physical address belong? Physical address belongs to the physical memory or main memory. So in order to fetch the instruction, suppose here the instruction I1 is stored, here the instruction of I2 is stored. So in order to fetch I1, CPU have to need to know the physical address of I1. But CPU doesn't know anything about the physical address. CPU simply generate the logical address, and we have to find the physical address corresponding to that logical address. So what happen in case of segmentation hardware? At first, the CPU will generate the logical address. This is our logical address, and logical address is divided into two parts. First part is known as the segment number. This S is the segment number, and this D is the segment offset. This is segment offset. Okay. So segment offset basically represent the location of a particular data inside the segment number. For example, suppose this is our segment 1. Okay. And in segment 1, there are what is segment? As logical address will belong to the segment. Actually, logical memory or logical or user program can be visualized as a set of logical address space. So, if there are 5 segments, then some address space, logical address will belong to this, some belong to this, some belong to this. Suppose there are 100 logical address for a particular program. Okay. Now, this space is divided into segment. Suppose 10 logical address belongs to this segment. This is segment 0, this is segment 1, this is segment 2, this is segment 3, this is segment 4. So suppose 10 logical address belong to SQRT segment S0. Suppose 30 logical addresses will belong to S1, and 40 logical address will belong to S2, and 10 logical address will belong to S3, and suppose 10 logical address will belongs to S4. So 10 plus 30, 40, 40 plus 40, 80, 90, 20. So there are 100 logical address. So if our program or our logical address space consists 100 address, and when we divided it into 5 segments, and let us assume, so these overall logical address will belong to different segment. So 10 segment belongs to S0, 10 segment 30 to S1, S2 40 segment logical address belong, and for S3 10 logical address belong, and for S4 10 logical address belong. So in the same way, if there is a segment S1 and 10 segment belong to S1, then logical address will be from 0 to 9. Okay. Suppose here A is stored, here D is stored, and for the logical address, suppose here E is stored. Okay. Now, if CPU want to access this D, then CPU will generate the logical address 9 in contrast to segment 1. Okay. So, if this, suppose this is 1 and this is 9, then this belong to segment number, segment 1, and this belong to the logical address in that particular segment. It means CPU want to access the data or want to access the instruction which is stored at the 9th position or 9th index in context to this segment number 1. Okay. But actually, where the program is stored, when it executes, that is stored in main memory. So we have to find the physical address corresponding to this logical address. What will be the physical address corresponding to this logical address? So once we know about the physical address, then we can simply provide the data to the CPU. Okay. After that, there is a segment table. Segment table basically contains what? It contains the starting and address of a particular segment where it is stored in main memory. Like see this. This is our segment 1, segment 0, segment 3, segment 4, segment 2. This is segment table, and this is complete program, and this is our physical memory. And here each segment is stored in non-contiguous fashion. Like segment 0 is stored from 1400 to this. Size of segment 0 is 1400. Size of segment 1 is 6300, and size of segment 2 is 4300. Size of segment 3 3200. Size of segment 4 4700. So this is the this is the basically base address, where it means the starting physical address to that particular segment. It means 1400 is the first physical address to the segment 0, and 1600 is the first physical address to segment 1, and 4300 is the first physical address to segment 2. Okay, and this is the limit. This is basically the size. Okay, so we have to load these segment into the main memory, and all this information is contained in a data structure which is known as the segment table. It basically contains 3 attributes. First one is the segment number. Second one is the limit. Limit attribute basically represent the length of the segment or size of the segment. And third attribute is the base or base, which basically represent the starting physical address of that particular segment. It means 1400 is the first physical address to the segment 0. So here, whenever the logical address will generate, then first we will check in the segmentation table whether this logical address is valid or not. What is our objective here? The objective of this segmentation hardware is to find the physical address corresponding to the logical address generated by the CPU. So whenever a logical address is generated, our first task is that we have to check whether this logical address is valid or not. So it will be checked in segmentation table. Okay, if this belongs to the limit, then it is a valid logical address. If it doesn't belong to the limit, then this is invalid logical address. For example, since this is segment number 1 and logical address belong from 0 to 9. So if this logical address is generated, then this is a valid logical address. But if I write it like 1 and 11, then this is invalid logical address. Why? Because this offset 11 doesn't belong to the segment number 1. So how we will check it? From the segmentation table. So if it is valid, it means if this page offset value is less than the limit value of the segment number, then we can say that logical address is valid, and now our task is to find the physical address. If this segment offset is greater than the limit value of the segment number, then this represents that logical address generated by the CPU is invalid, and simple there is an addressing error. So physical address will be found only when the logical address will be valid. So for this, once we found that physical address is valid, then logical address is valid, then in order to find the physical address, we will add the base value to this. Base value means the starting physical address of this particular segment. We will see it in example. So after adding the base value, we will find the physical address, and once we obtain the physical address, then the data is stored or instruction is stored at that physical address will be provided to the CPU. Once we summarize this, segmentation hardware. Basically, segmentation hardware is used to find the physical address corresponding to the logical address generated by the CPU. So in case of segmentation technique, when the CPU generate a logical address, that logical address is divided into 2 parts. First one is the segment number, second one is the segment offset. Basically, segment offset represent the position of the logical address corresponding to that segment number. For example, if we have a segment S1 and that segment contains 10 logical address numbering from 0 to 9. So these 0 to 9 logical address are valid logical address which belong to this segment number. So suppose CPU generate a logical address and we divided it into segment number and segment offset. So segment number is 1 and this is the segment offset. So this segment offset value is compared with the limit value of the segment which is stored in segment table, and if this segment offset value is less than the limit value, then it represents that a logical address generated by the CPU is a valid logical address. Now our task is to find the physical address. So in order to physical address, what we will do, we will add this segment offset value in the base address of the segment number, then we get the physical address. Second case is what? If this segment offset value is greater than the limit value of the segment number, then it will represent that addressing error. For example, if there is a logical address where the segment number is 1 and the offset value is 11, since 11 offset doesn't belong to this segment 1, so we will simply say that this is the invalid logical address. So this is the summarization of, or this is the working of the segmentation hardware. Let us these are the components which are used in the segment hardware. Here the logical address is divided into two parts, as I already explained, segment number and the segment offset. Segment offset represent the index corresponding to the, or logical address corresponding to the segment number. Segmentation table, this is another data structure which contains three things: segment number, limit or size of that segment, and the base address of that particular segment. And this segmentation table basically stored in segmentation table base register, which point to the segment table location. Well, actually the segment table is itself stored in the main memory or physical memory. So at which address the segmentation table is stored, because in order to check the offset with the limit, we have to find the segment table, we have to access the segment table, and in order to access the segment table, we must know the location of the segmentation table. So to maintain the, to record or to store the location address of the segmentation table, this register is used, which is known as the segmentation table base register, which point to the segmentation table location in memory. Here another register is used, segmentation table length register, which indicates the number of segments used by a particular program. It means how many segments are there in a particular program, or we can say that how many segments data is stored in a particular segmentation table. So in context to the segmentation table, two registers are very important, which we have to maintain. First one is the segmentation table base register, which contain the base address or the physical address of the segmentation table, because in order to access the segmentation table, we must know the address of the segmentation table where it is stored in physical memory. Second one is the segmentation table length register, STBR length. It means basically it represents, it store the number of segment for which we have to maintain the data in the segmentation table. So this is the basic description of the component of the segmentation hardware. Now see with the help of an example. So this is our logical address space, or we can simply say that this is a program. We have divided our program into 5 segments. This is segment 0, segment 1, segment 2, segment 3 and segment 4. These are the name of the segment. Like first segment 0 is for subroutine, segment 1 is a for sqrt or a defined function, segment 2 for main function, and this is for symbol table. Okay, so logical memory or logical address space is divided into 5 segments. Here this is our main memory or physical memory. It is divided into different physical address or different, it is not divided, it is basically a different physical address belong to the main memory. Now what happen, we have to store these segment into main memory, and since the segmentation is the non-contiguous memory management method, it means it is not necessary that memory space should be available in contiguous manner. Like here in this figure, the segments are stored in non-contiguous manner. For example, from this address to this address, segment 0 is stored. These addresses are blank. It means this memory space is available. No segment is stored in this memory space. After that, segment 3 is stored from this to this address, segment 2 is stored from this to this, segment 4 this to this, and this is blank. It means segment are stored in non-contiguous memory manner in the non-contiguous manner in the main memory. So this is our segment table or data structure, which contains 3 fields: segmentation number, limit, and base. Again, this is the segment number 0. It means limit means size segment number as 0. As 0 basically contain 1000 logical addresses. Okay. Here this is S1. S1 contains 400 logical addresses. S2. S2 again it contains 400 logical address. S3 contains 1100 logical address. S4 contain 1000 logical address. Okay. So this is the size of a particular segment, and basically size represents that how many logical address belongs to that particular segment. So for segment 0, 100 logical addresses belong. For segment 1, 400 logical addresses belong. For segment 2, 400 in this manner. Okay. And this is the base address. It means the starting first physical address to segment number 0 is 1400. It means the segment 0 is from 1400. This is also included, plus how many is size? 100 is the size. So 1400 belong to this. Okay. So up to 2399. These are the physical addresses which belongs to segment 0. Understand this very carefully, since this is the first logical address which belongs to segment 0. So this belongs to segment 0, and the size of segment 0 is 1000 logical address. So when we will include this, then the last physical address will be 2399. Okay. So this is the first physical address. 1400 is the first physical address for the segment 0, S0, and this is the last physical address for the segment S0. Okay. So let us see with the help of an example. Segment 2 size is 1400, and suppose we have to this is the starting location, thus reference 53 of segment 2. It means we have to find the logical physical address corresponding to segment 2 and 53. This is the logical address generated by the CPU. Now we have to find the physical address. So first we find that whether this offset is valid or not, whether this logical address is valid or not. So we will check this in the limit of 2. Limit of 2 is 1400. So this will belong to segment 2. It means this is a valid logical address. Now in order to find the logical address, physical address, what we will do? We will add this offset with the base address of segment 2. And what is the base address of segment 2? Is 4300. So 53 plus 4300. It means 4353 will be the physical address. Okay. So in the same way, we will find the the physical address corresponding to all the logical address. A question on the this type of problem is asked in AKTU exam. So we have to find the we have to given a table of the logical addresses, and we have to given this table is also given. Now we have to find the physical address. So in order to find the physical address, first we check that the offset is valid or not. If it is valid, then add the base address of that segment in order to find the physical address. Okay, thank you.